Good morning, students. Our today's topic in the subject of mathematics D4 in the class of O levels is further graphs and graphs applied to kinematics. So here is our introduction. When we travel from one place to another, we often talk about time, speed, and distance. When two motor car enthusiasts talk, they will usually bring up terms like acceleration and the time needed to reach a maximum speed. The study of moving objects in relation to distance, time, speed, and acceleration without consideration of their causes is known as kinematics. So concentrate yourself. We are going to start some questions. Here is our first question. A part is convert the speed 36 meter per second into kilometer per hour. Second part is convert the speed 72 kilometer per hour into meter per second. And C part is a wheel of radius 14 centimeter is turning at 30 revolutions per minute. Find the speed of the point of the rim of the wheel, giving your answer in meter per second. So concentrate yourself. We are going to start its solutions now. So look now. We are converting 36 meter per second into kilometer per hour. The first thing that you have to understand is in 1 kilometer, there are 1000 meters. And in 1 hour, there are 60 minutes. And in 1 minute, there are 60 seconds. The next thing to remember is when we go from larger unit to smaller unit, we multiply. And when we move from smaller unit to larger unit, we divide. So these are the important concepts which you have to understand and learn first. Now look here. 36 meter per second is going to be converted into kilometer per hour. So actually we are moving from smaller unit meters to kilometers. So smaller to larger division concept will be applied. So look now, in 1 kilometer there are 1000 meters. So that's why we have to divide 36 by 1000. And in denominator we have seconds. So second is going to be converted into hours. And in 1 hour, there are 3600 seconds. So in the denominator, 1 will be divided by 3600. So second will be converted into hours. Now this fraction will go to the numerator and we have to take the reciprocal of this one, solve it on the calculator. So this will be the answer. Here is the B part, that is the reverse of the A part. Now we are going to convert kilometer into meters and hours into seconds. So look now, we are moving from larger to smaller unit. So multiplication concept will be applied. So in 1 kilometer, there are 1000 meters. So that's why we will multiply 72 with 1000 to go from kilometer to meters. And in the denominator there are 1 hours. So hour is going to be converted into seconds. So we will multiply 1 with 3600 seconds. Okay, now you solve it on the calculator. You will get the answer. Unit will be meter per second. In C part, it is given that the radius of the circle wheel is 14 centimeter. So the distance traveled by a wheel, the distance in one revolution will be 2 pi r. And because it is also given that it is turning at 30 revolutions per minute, so 30 will be multiplied with it. And this will be the distance in centimeters. So in 1 minute, a point on the rim moves 30 into 2 pi r. So 30 is here, 2 is here, pi is here, and r is 14 centimeter. Hence its speed is equal to distance over time. So this is the distance which will be placed in numerator over time. time is actually in 1 minute per minute. So in 1 minute there are 60 seconds. So solve it on the calculator. You will get the answer. Unit will be centimeter per seconds. Okay, but requirement was convert your answer in meter per second. So we are moving from smaller unit to bigger unit. So in the numerator, we will divide this value by 100 because in 1 meter, there are 100 centimeters. Okay, so divide this value by 100. So point will move 2 places to the left. So answer will be 0.43988. So meter per second. So this is the answer. The next thing that we are going to read is the gradient of a curve. So concentrate yourself. We are going to start. When a line L1 touches the curve at P, so look now, here is the curve and here is the point P. L1 is called the tangent to the curve. So if the line touches the curve at only that point P, so it will be called the tangent to the curve at point P. Okay, when a line L2, so look now, here is the line L2 that touches the curve at Q. L2 is called the tangent to the curve at Q. So this is called the tangent to the curve at point Q. So the gradient of the curve at a point is defined as the gradient of the tangent. So look now again, the gradient of the curve at a point is defined as the gradient of the tangent. Here is a question. The variable x and y are connected by the equation. So this is the equation. Corresponding values of x and y are given in the table below. So here is the table that is given. A part is calculate the values of a and b. Okay, to find the value of a, we will put x is equal to -1 into the equation. Solving it will give us the value of y. And putting the value of x is equal to 2.5 into the equation will give us the value of b. So this will be a part. Okay, b part. Taking 2 centimeter to represent 1 unit on the both axes. So it means scale is already given. We have to follow the condition. Draw the graph of this one. So these set of the values will be plotted on the sheet of the graph paper by taking this scale. So look now. Okay, this is the scale that we have taken according to the condition. 2 centimeter to 1 unit on x-axis and 2 centimeter to 1 unit on the y-axis as well. And these dots are actually the set of the values which we have taken from the table. So after plotting these points onto the sheet of the graph paper, the curve will be made, sketched with freehand. So this is the curve which we have sketched with the help of the points which we have made in the table. Okay, C part is here. By drawing a tangent, find the gradient of the curve at the point x is equal to 1. So on the sheet of the graph paper where the curve has been made, we will draw a line on x is equal to 1 in such a way that the line touches the curve at only one point, because it is required that by drawing tangent. So tangent is a line that touches the curve at only one point. So look now. So here is x is equal to 1 and here is the point on the curve where x is equal to 1. So we will make a line at this point in such a way that the line touches the curve at only one point, that is x is equal to 1. So this is the tangent to the curve. Now the requirement is find the gradient at this point. So the way is we will make a right angle triangle at this point. So this is the right angle triangle. So you may make a smaller or greater triangle, this one. So but the triangle must be appropriate size, that must not be too big or too small. You may make the triangle here as well. Okay, the next thing that is required is gradient is equal to rise over fall. So this is the rise and this is the fall. So you can see from here 1, 2, 3, sorry, 1, 2 and 3 big boxes are covered and two boxes are representing by 1 unit. So 1, 2 and 3 boxes will represent 1.5. So rise is 1.5 and fall is 1 and 2 boxes, and two boxes are represented by 1 unit. So rise over fall. So it means 1.5 over 1 will be the gradient. So here is the solution of the C part. A tangent is drawn to the curve at the point x is equal to 1 from the graph. The gradient is rise over fall, that is 1.5 over 1. So 1.5 is the answer. So the D part is use your graph to estimate correct to one decimal place the values of x satisfying the equation 5x minus x square minus 1. So remember one thing, when this kind of the part come in the question, that is always connected with the original equation. So come now, we will solve it now. So look now, this is the part that is given in the D part. So we will transform this equation according to the original equation of the curve. So look now, 5x minus x square will remain here and this minus 1 will go to the right side, that is 1. Okay, now we need 1 by 2 to make this equation according to the original equation. So we are going to multiply both sides with 1 by 2. So 1 by 2 into 5x minus x square is equal to 1 by 2. So if you can see, this is the original equation now. And on the right hand side, we are given 1 by 2. So actually on the right hand side in the original equation, there was y. So actually y is equal to 1 by 2 now. So we will make this line on the graph now, and the point of intersection of this line and the original curve will be the solution of this part. So look now. So here is the line, that is y is equal to 1 by 2. So look now, here is the line. So this line is intersecting the original curve at this point and at this point. So look now, if two big boxes are representing by 1 unit, so in two small big boxes there are actually 10 small boxes. So it means one small box will be represented by 0.1. So this point will be 0.2 and this point will be 4.8. So 0.2 and 4.8 are the solution of D part. So look now, the solution is given by the points of intersection of the curve and the line y is equal to 1 by 2. From the graph, x is equal to 0.2 and 4.8 are the solutions of D part. E part is by drawing the line 2y is equal to x plus 2 on the same graph, find the range of the values of x for which 5x minus x square is greater than x plus 2. So again, understand, the all parts are connected. So first we will make the line of this equation by taking x2 3 values, that is x1 2 3, and accordingly y's values will be obtained, and then set of values will be plotted on the sheet of the graph paper to make this line. So come now, we will understand, and then we have to find the range of this thing. So look now, here is the line of 2y is equal to x plus 2, and this line is actually intersecting at this point B and this line, this point A. So A is here, that is 0.6, and B is here, that is 3.4. So 0.6 and 3.4 are the point of intersection of this line and the curve. So look now, the line 2y is equal to x plus 2 intersect the curve at A and B. This was 0.6 and this was 3.4. So look now, this was the condition given in E part. So we will multiply both sides by 1 by 2. to make this the original equation, and now this is the line. So thus the values of x for which 1 by 2 5x minus x square is greater than 1 by 2 into x plus 2 occurs in the region between a and b. So greater than a, so that will be x greater than 0.6 and lesser than 3.4. So x lesser than 3.4. So this is the approximate range of the values. So this is the answer. Here is another question. A train started from A and traveled to a point 8 kilometer from A. Okay, look here. So distance is 8 kilometer. The following readings of the time in minutes since leaving A and the distance in kilometer from A were taken. So these are the set of the values which are obtained from the this journey. Draw a graph of these values using a scale of 2 centimeter for 2 minutes on the horizontal axis and 2 centimeter for 2 kilometer on the vertical axis. So this is the scale which is given. So we have to follow the scale. So look, now we are going to draw this set of the values onto the sheet of the graph paper. So look, now according to condition, 2 centimeter to represent 2 minutes on the horizontal axis and 2 centimeter to represent 2 kilometer on the vertical axis has been taken, and these set of the values are plotted from the table on the sheet of the graph paper, and with the help of the free hand we have sketched this curve. So A part is here to estimate the time taken to travel the first 4 kilometer, and B part is to find by trying the tangent the speed of the train in kilometer per hour 5 minutes after leaving A. So this is the condition. So again, look, the speed of the train in kilometer per hour 5 minutes after leaving A. Okay, remember one thing, the tangent of the distance time graph always represent the speed. So when we will find the gradient of the speed, distance time graph, that will represent the speed. So now the A part is to estimate the time taken to travel the first 4 kilometer. So here are 4 kilometer. So with the help of scale, we will make a horizontal line that will touch the curve, and from there we will make a vertical line to touch the horizontal axis. And here is the time. So actually 10 small boxes representing 2. So it means one small box will represent 0.2. So it means this will be 3.8 minutes. That will be the answer for traveling the distance covered 4 kilometer. So look, now here is the answer from the graph. The train takes approximately 3.8 minutes to travel the first 4 kilometer. The B part is to find the drawing a tangent the speed of the train in kilometer per hour 5 minutes after leaving A. So 5 minutes after leaving A. So here is 4, here is 6, and the exactly midpoint will be 5. So this is the 5 minute time on the curve. So at this point we will make a tangent. Tangent is a line that will touch the curve at only this point. So this is the tangent at 5 minute time to the curve. So from here we will make a right angle triangle. So it will be up to you whether you make a bigger triangle or a smaller, but it should be a right angle triangle. So now the gradient is a rise over fall. So look, now from here, so actually 1, 2 and 3 big boxes are complete. Here one small box is left, so one small box will make here, that will make one big box. So 1, 2, 3 and 4 small big boxes are there, and then 2 small boxes are also there. So 4 will represent 4 kilometer, and 2 small boxes will represent 4.4. So 4.4 is rise, okay, and then fall. From here, one big box, two big box, three big box, and four big box. So four big box stands for 4. So 4.4 over 4 will give us the answer. But listen now, rise is kilometer and fall is minutes. So this will be the unit after solving it. So look here, a tangent is drawn at the 5 minute after leaving A. The gradient of the tangent is 4.4 over 4 kilometer per minute. So we are going to convert this minutes into hour. So in 1 hour there are 60 minutes. So we will divide 4 by 60. So look now, this 4.4 is still here, division sign is here, and then 4 by 60. So this will give us the unit kilometer per hour. So this is the answer, 66 kilometer per hour. The next thing that we are going to read is the speed time graphs. So concentrate yourself, we are going to start now. Very important point to remember is the gradient of the distance time graph gives us the speed, whereas the gradient of the speed time graph will give us the acceleration. Here is the first question of the speed time graph. So look now, the graph shows the speed of the body over a period of 10 seconds. So this is our 10-second graph. So find apart the acceleration during the first 2 seconds. So here are first 2 seconds. So the acceleration will be gradient of the speed time graph. So first 2 seconds, so this is the first 2 second graph. So gradient will be rise over fall. So rise is 2 centimeter and centimeter per second, and fall is 2 second. So look now, 2 centimeter per second over 2 second. So answer will be 1 centimeter per second square. So this is the acceleration during the first 2 seconds. B part is the total distance traveled during the first 2 seconds. So first 2 seconds distance is area under the graph. For the first 2 seconds, the area under the graph is the area of a triangle. So area of the triangle is 1 by 2 into base into height. So base is 2 and height is also 2. So 1 by 2 into 2 into 2. 2 will be cancelled. So answer will be 2. And because this is the area, so distance traveled during the first 2 seconds is the area under the graph, where t is equal to 0 and t is equal to 2. So distance traveled is 1 by 2 into 2 into 2. So 2 will be cancelled. So 2 centimeter is the distance traveled in the first 2 seconds. The C part is find the average speed during the 10 seconds. So the average speed is total distance over total time. So this is the formula, total distance over total time. So because total time is given, that is 10 seconds. So first we will find the total distance in 10 seconds. So we will find the area of A, that is a triangle, then area of B, that is a square because it is 2 by 2. Then the area of the trapezium C, and finally the area of the trapezium D. So look now, in triangle the base is 2, height is 2. In square the dimensions are 2 by 2. In trapezium the parallel sides are 2 by 2 and 8, and the perpendicular height is 2. In the bigger trapezium the parallel sides are 8 and 10, and the distance between the parallel side is 4. So we are going to put these values into the formula. So look now, So look now, the distance traveled during the 10 seconds is the area under the graph for the 10 seconds. So distance traveled will be equal to area of A, area of B, area of C, and area of D. A is a triangle, so the formula will be 1 by 2 into 2 into 2. That is 1 by 2 into base into height. 2 will be cancelled, so 2 centimeter is the answer. B was a square, so square's area is L square. So that's why 2 into 2, that is 4 centimeter is the area of B. C was a trapezium. The formula is 1 by 2 into sum of parallel sides into perpendicular height between the parallel sides. So parallel sides were 2 and 8, and perpendicular height is 2. So 2 will be cancelled by 2. So 8 plus 2 is 10 centimeter. Whereas the D was also a trapezium. The formula is 1 by 2 into sum of parallel sides into perpendicular height. Perpendicular height was 4 and parallel sides were 8 and 10. So look now, 2 2s are 4. 8 plus 10 are 18. 18 2s are 36. So this is the area of D. Finally, we will add these four areas A, B, C, and D. So 2 plus 4 plus 8, 10 plus 36, this is the total area. So the average speed is total distance over total time. Total area is 52. Our distance is 52 and total time is 10 seconds. So after cancellation, 5.2 centimeter per second is the average speed. Here is another question of speed time graph. So look now, a particle moves along a straight line AB so that after t second its speed v meter per second in the direction AB is given by. So this is the equation which is given us the speed time relation. The corresponding values of t and v are given in the table. Calculate the values of k and h. So look now, here is k. So we will put t is equal to 3 into the equation. That will give us the value of k. And when we will put 5 in place of t in the equation, that will give us the value of h. So this will be the method to find the value of k and h. Okay, further, taking 2 centimeter to represent 1 second on the horizontal axis and 2 centimeter to represent 5 meter per second on the vertical axis. So it means time will be taken on the horizontal line according to this scale and speed will be taken on the vertical line according to this scale, 2 centimeter to 5 meter per second. So we are going to plot these values on set of values on the sheet of the graph paper. So look now, here is the scale that we have obeyed, that is 2 centimeter to represent 1 second on the horizontal axis and 2 centimeter to represent 5 centimeter 5 meter per second on the vertical axis. So this is the speed and this is the time in second. So after taking the scale, we are plotting the set of the values on the sheet of the graph paper, and then with the freehand that curve will be sketched. So this is the first part. A part is find the value of t when the speed is 10 meter per second. So look now, here is the graph and here is the 10 meter per second speed. So with the help of scale, we will draw a horizontal line that will cut the curve at this point and at this point. So look now, because 2 centimeter are represented by 1 unit, so it means one small box will be 0.1. So this point is 0.8 and this point is 4.2. So 0.8 and 4.2 seconds are the time when the speed was 10 meter per second. So look now, here a part from the graph, t is equal to 0.8 and 4.2 seconds are the time when the speed was 10 meter per second. The B part is the time at which the acceleration is 0. So because this is a speed time graph, the acceleration will be the gradient of the speed time graph. And we need when the acceleration is 0. So the acceleration will be 0 when the gradient will be 0. So gradient will be 0 at the maximum or the minimum point of the curve. So this is the point where the gradient will be 0. So this is the point that is 2.1, 2, 3, and 4. So 2.4 second was the time when the acceleration is 0. Here is the B part. The acceleration is 0 when the gradient of the curve is 0. From the graph, the acceleration is 0 at t is equal to 2.4 seconds. The C part is the gradient at t is equal to 4 and explain what this value represents. So we will draw a tangent at t is equal to 4 to the curve, and we will find the gradient that will be rise over fall, and that will represent actually the acceleration of the journey at t is equal to 4. So here is the graph, and this is the 4 second. So here is the point. So at this point, we have made a gradient at tangent that is a tangent to the curve at t is equal to 4. So at this point, at this line, we will make a right angle triangle. So look now, if suppose this is the right angle triangle. So this is a small right angle triangle which I have made. So look now, on the vertical axis, one small box will represent 0.5, and on the horizontal axis, one small box is 0.1. So look now, 1, 2, 3, 4. 4 boxes on the horizontal line, that is 0.4. And on the vertical axis, one big box, and then almost 1.5. So actually 2.5, 3, and 3.25. So we will solve it on the calculator. So look now, 3.25 divided by 0.4. So this is the gradient of the curve, that is 8.125 almost. So that will represent the acceleration of the journey at t is equal to 4 seconds. So look, a tangent is drawn at point t is equal to 4 from the graph. Gradient of the tangent is equal to 14 over 1.7. So it has made another right angle triangle. That will be up to you what kind of the triangle you made, but it must be right angle triangle. So look at the answer. So answer is like as that of ours answer. The next part is the time interval when the speed is less than 15 seconds. So we will first check out where the speed is 15 meter per second, and with the help of scale we will draw a horizontal line. So look now, here is the 15 meter per second speed. So we will draw a horizontal line from here that will intersect the curve. So it is intersecting here and here. So the requirement was the speed less than 15 meter per second. So again look, so less than 15 meter per second will be the lesser area. So this is the point at which it is touching. So that is 1, 2, 3, and 3.5. So 0.35 seconds. And this is the other point. So this is 4.5, 4.6, and 4.65. So this is the time that should be greater than 0.35 second and lesser than 4.65 seconds, between which the speed will be lesser than 15 meter per second. So look now, the time interval for which the speed is less than 15 meter per second is t is greater than 0.35 seconds and lesser than 4.65 second. So this is the time interval. Here are the graphs in practical situations. Figure 2.11 shows three containers, each of which contains liquid of height h centimeter, and the liquid are of the same volume. Okay, each container is being filled with a liquid at a constant rate from the tap. The containers are initially empty. The graph which shows the height of the liquid as the container is being filled is shown beside the container. So in A part, you can see the straight line graph will be obtained because the graph is a straight line with constant gradient as the water level rises uniformly. So in the B part, you can see we will obtain this kind of the graph. Initially, the up to here, the straight line graph is obtained because the water level rises uniformly up to here. But after that, the water level will rises more speedily. That's why it is bent upward. In this C part, you can see the graph is like sloping downward because the in the bottom the water level will rises more speedily, but as we go up the water level will rise with less speed because the radius is getting more and more as we go to the higher point in the container. Here is another question. The graph shows the speed time graph of moving object over a given time. Given that the distance covered in first 8 seconds is 80 meters. So in first 8 seconds, the distance covered is 80 meters. Look now, calculate the maximum speed. So the maximum speed is required. So the formula is for this distance, find to find the distance in first 8 second, the area under the graph will be the answer. So that is a triangle, so 1 by 2 into 8 into v should be equal to 80. So look now, 1 by 2 into 8 into v is equal to 80. So from here, 2 4s are 8 and this 4 will go to the denominator of 80. That will make 20 meter per second. So v is equal to 20 meter per second. So look now at the graph again. So here is the graph. So it means v is 20. Okay, second part is the acceleration for the first 8 seconds. So again, we are here, that is up to 8 seconds. So the gradient of the graph will give us the acceleration because this is a speed time graph. So gradient will give us the acceleration. So rise over fall. So rise is 20 and fall is 8. So 20 by 8 will be equal to, so look here, 20 by 8 will be equal to acceleration unit will be meter per second square. So look further into the question. So here is the question. Third part is the value of k and h. So look now further. The total distance traveled in first k seconds is 400 meters. So up to here is k seconds and distance given is 400 meters. Up to here the distance is 80 and this is a rectangle whose dimensions are 20 into k minus 8. So 20 into k minus 8 will give us the area of this one plus 80 will be equal to 400. So look now. So 80 plus 20 into k minus 8 is equal to 400. From here, solve the equation. You will get the value of k. Okay, moving further. Look now into the question again. So in the next part, the value of k and h. So h is required now. So look now, and that the deceleration during the last part of the journey is 20 meter per second square. So from here to here, deceleration is 2 meter per second square. So deceleration is the negative part of the acceleration. So actually the gradient will be equal to 2. So rise is 20 and fall is k, sorry, h minus k. So k is already we have find out. So we will put the value of k and we will get the value of h. So look now into the question again. So 20 over h minus k is 24. So putting value of k here, you will cross multiply the values and will get the value of h. So the next thing that is required is sketch the distance time graph and the acceleration time graph. So first we are going to sketch the distance time graph. So look now, actually from the speed time graph, we can see there are three junctions. One is 8 second, then k second, k was 24, and then h was 34. So look now, given that the distance covered in 8 seconds is 80 meter, so this is the first point, 8 and 80 meters. So this is the first point that will be plotted on the sheet of the graph paper, because it is given that 8 seconds and 80 meter. Next is the total distance covered in the first k second is 400 meter. So look now, we have obtained the value of k is 24. So 24 and 400 will be the second point, and the next will be, so from here you can see the k a second. So h was obtained. So look here again, h was obtained 34. So first we will find the distance moved in the last part of the journey. So the last part was actually a triangle. So 1 by 2 into base will be h minus k and height will be 20. So look now, this is the distance moved in the last part of the journey, that is 1 by 2 into 34 minus 24. So h is 34, k is 24, that's why 34 minus 24 into height is 20. So solve it, that is 100. So look now, this is the last part's journey. So again look into the question. So up to k seconds 400, so it is up to this 400 distance covered, and this further is 100. So it means total distance covered up to h second will be 500. So h was 34. So 34 and 500. So these are the 3 points which we will plot on the sheet of the graph paper, and we will join with the freehand curve to get the distance time graph. So look now, here are the x's, and we have taken 1 centimeter to represent 2 unit on the horizontal axis for 2 seconds, and 2 centimeter to represent 80 unit on the vertical axis, that is representing distance in meters. So the points are here. Number 1 point is 8 and 80. The second is 24 and 400. And the third one is 34 and 500. And with the help of freehand curve, you will sketch the curve that will touch 0 point, because distance has been started from 0. So this is the distance time graph. Okay, the last thing is the acceleration time graph. Okay, from here you can see for the first 8 seconds, the acceleration was 2.5 second. So again, I'm telling you, for the first 8 seconds, the acceleration is 2.5 seconds. From 8 to k was 24, and h was 34. So from 8 to 24, the acceleration will be 0 because this is a horizontal line. And from 24 to 34, the deceleration is, so look now, deceleration is 2. So there are three parts. Again, listen. For the first 8 seconds, the acceleration is 2.5 seconds. From 8 to 24, the acceleration will be 0. And from 24 to 34, the deceleration is 2, that is -2, because deceleration stands for negative value. So from 24 to 34 will be -2. So look now the graph of the acceleration time graph. So look now, for the first 8 seconds, the acceleration is maintained at 2.5. Then from 8 to 24, the acceleration is 0, again a horizontal line, because acceleration is maintained at 0. And then from 24 to 34, the acceleration was -2. So look now, this is -2. So acceleration was maintained at -2. So this is the acceleration time graph.